Good morning, everyone, and welcome to week 11. We are taking a look at chapter 10 this week. It's more information about PACS and how we archive the patient records. Your assignment for this week is to read that chapter and complete those review questions. Those are due by Sunday. There is also a quiz over chapter 9 and 10 that's due on Sunday. And there is also a Konica assignment. So I want you to start taking a look ahead at your project. So last week you should have started to take a look at what those requirements were for that final project for writing your memo. And I want you to start getting familiar with some of the other pieces of equipment other than Fuji and Delworks that we're using in lab. So one of the assignments that I have you taking a look is Konica, because a couple of our facilities have Konica systems. Like if you're going to McLaren Bay, you'll be using Konica. So when you go into this folder for Konica, you're going to notice that there is a couple videos that you're going to take a look at. And it's a DR plate that you're going to be purchasing for the department. So you're taking a look at a salesperson who is trying to sell you this device. Kind of keep in mind that anytime you're looking to purchase a DR plate in the future, this is what you're going to do. You're going to have the salesperson that's going to come into the department, and they are going to be throwing out all kinds of terms that you've learned this semester, and you need to be able to identify what they're talking about. So I want you to watch this video, listen to what he's saying in the video. I only picked the Konica because we don't have it in lab. It's something that I want you to be familiar with just because, again, you're going to be using it. So when you go into your tab and you pull up your digital project by Konica, you'll see the links are attached in the assignment. And I want you to watch those, and then you're going to answer these questions that the rep was talking about. When you go to do your memo, I want you to decide what system you like. You don't have to go with Konica. You don't have to go with Fuji. If there's another system that you've been researching and you're really interested in that particular plate, then you can certainly focus on that. You don't have to use one of these that I've attached. So don't feel like you have to do that section. So only those couple things. You got to read chapter 10, answer those questions, take your quiz, and then complete that Konica assignment for this week. So let's take a look at the content that I have you doing this week. So chapter 10 is your PACS archiving. When you get into this chapter, that's pretty much all it talks about, is how these images are archived. Used to be back in the 80s, 90s, early 2000s, everybody had film rooms. And so we would take our images, we would process them, we'd put them into a film jacket. Those film jackets would get stored in a room that looks like this. And you would have to pull those film jackets every time you had a patient. So we had film room attendants that would grab out our films, bring out the entire jacket, and they would bring that to us. And then if the radiologist wanted to see old films in addition to the films that we took that day, we would put those all up on their view boxes. Now we don't have to do that because everything's stored electronically in PACS. And so this is an archiving system that all of the hospitals are using now. They do have to be DICOM compatible so that any machine talks to PACS. So you're going to hear the term PACS a lot when you get out to clinical because everybody uses it. So basically it's a storage area for patients. It has all of their data stored with it. So any reports that we've done, any thing that's been dictated by your radiologist gets stored in there. And so you have access to all of these in PACS. One of the things that I want to caution you on when you're out there is, let's say Aunt Jane had some images and she wants to know what the report said. You cannot go into another person's file just to take a look at their report. So even though we have access to PACS because of HIPAA, we cannot go in and take a look at people's records. So the only people that you can open their records for is whoever your patient is for. So keep that in the back of your mind that you don't have access to anybody's documentation. So your PACS system is basically a way to control what we're storing. It's historic images, it's the new images that we've taken. There are a lot of facilities that are keepers of PACS now, so you'll see a lot of companies that have archiving systems to store these images for hospitals that are off-site. So we're seeing a lot of growth taking place, especially when you're looking at a family doctor's office that's not part of the hospital system. Let's say they're a foot doctor or they're a med center, so like Hope Urgent Care here in town. They're not part of a hospital system, but they still want to archive their PACS images. They could go through somebody like Radiology Information Systems, RIS, and they would store those documents for them. So there are some outside companies that you could hire to store your documents. So your storage capacity will probably double every 18 to 24 months because they tie up a lot of gigabytes. So as we see more and more capacity being needed, that's why you're starting to see a lot more outside vendors providing that service for storage. So you need computers, you need storage space, you have to have the hardware and the software in order to do that, and that's what your hospital servers do or their outside agency. We want to make sure that we have masters in all of our databases. So a master copy is stored. So even when you are doing an image in lab, there's that original image that you've taken that automatically gets stored, and then whatever changes. So as soon as you submit, that's why when I had you watch that PACS video, it's hard to undo because that master copy's been saved. So you have to go to your PACS person and you have to explain to them what happened. So there's a control process in place with those, and that's going to be that PACS administrator when you run into any difficulties. So our image manager is going to run a reliable database, and some of those are Sybase or Oracle. You may see some other systems out there. Those are more of the common ones. They have a structured query language, and they're going to store that data on that archive server. Your database is going to be mirrored, so if one database goes down, then there's another one in the backup server. Image Manager is a PACS component that interfaces with that RIS that I was talking about. So everyone's going to have a Radiology Information System software. So we have RIS, and then your hospital system has a HIS, which is your Hospital Information System. So they store all of the medical records where you're storing just the radiology information. Our interface with PACS will be compatible with both systems, so that's part of that DICOM deal. It has to be able to communicate with those other programs. So your image manager can play a pretty key role in populating image information into that hospital electronic medical record. And one of the things that I had you take a look at last week was, were you using an electronic medical record? And most of you had said yes. You're using something that's powered by Epic. And so I told you when you get out there, you're going to get training in Epic so that you understand how that entire system uses. So Epic's a very popular software with the hospitals, and that's what they're all going with because it's pretty user-friendly for the staff and for you in the department. So I also had you look at a video at how that information gets put into the file and what it's able to do in PACS. And so this is just kind of a reminder that your information has to include your patient name, identification, exam date, ordering physician, and location. Those are all requirements for your medical record and your X-ray image. Those fields are going to be organized, so we can't move these around. There's a set way that they're put in, and we're going to enter that documentation that's required. So your order is going to be placed in RIS. There's going to be a front desk person that puts that information in for us, and then that order gets sent back into the department, and you're going to pull that order off of the computer to go do your images. Those images are going to be acquired, and then they're going to be sent into the archive, and that's where your radiologist can pull it up to take a look at it and do his dictation. So that image storage or archive server is going to consist of physical storage device space. Most of those will have a tier. You're going to have a short-term, a mid-term, and a long-term storage area. And that archive system is going to have a backup tier. So So short term just means that it's usually available 3 to 5 seconds. So if you're at your computer and you've just taken your image, it's going to pop up and then it's going to store it for 3 to 5 seconds. Midterm range is you can still access that file and pull it up after you've taken your image. Long term is when it gets sent off to the radiologist. Now it's going to get stored into long term, and that can usually take up to 1 to 5 minutes. Your RAD is going to look like this. So you have several magnetic disks, which are hard drives. They're going to link together, and they work together to store that image. So this is what a short-term storage unit's going to look like. It is going to be in terabytes now. So we used to have devices that operated off of gigabytes, but you're even seeing with your laptop computers, they all operate off these terabytes now. So this disk size can be increased. And it comes in different levels. It just depends on the hospital or the urgent care's need as to how much storage space that they're going to have. So in 1988, Patterson, Gibson, and Katz came out with a paper that talked about these redundant arrays of inexpensive disk. That's what that acronym stands for. And so what we use was designed by them. And this is the different RAID levels that you are going to use when you're out there. So at RAID 0, your data is going to be stripped. And so that stripping, that data is going to be broken up into tiny pieces, and that information gets stored. So that's what this looks like. So it goes through and it talks about these different storage capabilities. So when we get to tier 1, that means that it's going to be mirrored onto 2 different disks. You get into tier 3, it's going to strip that information, it's going to correct it. When we get to RAD 5, you're going to partially write over the disk. So it's going to look something like this. And so it's going to strip that data, it's going to correct that data, and then the performance data takes place at this level. Long-term storage is important because this is how we're going to pull our information off of PACS. And this is how, if your patient goes across town to see a specialist, they're going to pull from that long-term storage. So it's very cost-effective for hospitals to have this system in place. It's going to widely use optical disc tape and those magnetic discs that I was just showing you. So it kind of looks like a jukebox that's going to hold all those tapes and discs together, and then it interfaces and loads the information up when we need it. So this is what that optical disc is going to look like inside. It's very similar to a CD or a DVD, and it's going to be read with a laser. It's pretty reliable, and it's pretty fast, and it's going to have a long-term storage capability. So these then move to digital video disc, so these DVDs. And what's nice about the DVDs is you can hold a lot of data on one DVD, and your patient can take this DVD with them to another facility that doesn't have PACS. Then we get to these ultra-dense little optical, they're kind of like floppy disk. And with these, you can read them with a blue laser technology. Typically, they were used in 2006. We've moved away from these floppy disk. So your tape libraries, again, were in 2006. They looked like this. They'd store data on it, and you would take this out kind of like a print cartridge, and you'd load that in to store data. So they were pretty cheap to use because you could just change them out like you would with your printer. So the tape, this is how it would be stored. It looks just like a jukebox, but pretty big. It has a robot arm that moves those discs around. The problem with those is there's less reliability over multiple uses. That tape can wear after long-term use. So that linear tape opened up, and it was a new formatting technology. Basically, it was a high-capacity tape technology that was used to store and compress data. So this was invented in 1984, and it was licensed in 1994. And that storage capability was 40 to 160 gigabytes. But like I said before, we're moving to terabytes now because we have a lot more images. Think about when you do a CT, how many images? There could be up to 500 images or more on one patient that needs to be stored. So the gigabyte doesn't give us much storage. So these magnetic tape technologies Even though they were an advanced intelligent type of tape used back in the 96s, they just didn't have enough storage capability. So these magnetic tape discs came around. So they're a direct attached storage. They work with the network and they're a storage area, and they look something like this. And this is where it's going to connect to the cable connection so that you can pull those images up quicker. And that network storage and standalone RAID arrays can connect directly to your network. So those storage area networks are called SANs, and they're a high-speed special network or subnetwork that's going to link that data into those associated data servers, and then they will pull the data from there from PACS. So these became very popular in healthcare because it was cheap and it stored more information. So you can still take advantage of when they're using in conjunction with SAN. The PACS archives are chosen more for these reasons of need, cost, and compatibility. If there's no capital funds or personnel are available to implement or operate the complex archive, facilities seek other alternatives, and that's where they go to outside providers, and then they end up paying per use, but most of them will pay per month for those services. So they can provide the latest and greatest hardware and software, and they can go in and they can manipulate your computer off-site. They don't have to come to the campus in order to correct something that's going wrong with your software or program. So they're responsible for that day-to-day management of your archive system, and they can bring it up and run it without any issues. So these give you a short-time archive located at the hospital, but the long-term archive is going to be handled with that outside company. So it's pretty convenient for a hospital system where, like I said, somebody who is working in a small urgent care that's not part of that hospital system. So your short-term archive may be leased from that ASIP, and they can control prefetch images from that long-term site that they want to view. So disaster recovery plans for your hospitals are going to require that they have a long-term storage unit, and it's going to be located off campus. So every large institution is going to have some type of storage for disaster purposes located probably a good 10 to 20 miles off of campus. So your disaster recovery involves making copies on tapes or discs, and they store them at another location. Then that way, if your frontline archive goes down, they're able to pull those images back up. So they're always going to have some backup plan. There's three components that are common in PACS. You're going to have a film digitizer, an imager, and a CD burner. Those film digitizers are another way to take that radiograph, and they're going to convert it to a digital format. And they can do this by using a digital that scans. And so they kind of look like a view box. You put that up just like a printer. Think of a printer standing upright. You put your film on there, and it's going to have a bar that goes across, scans that information, and feeds it into the software. This can work off of laser technology, CCD technology, and they can be pretty inexpensive. So they could look something like this, where even you feed the film in, and then it scans that just like your printer scans a piece of paper and stores it into the computer system. So those digitizers do use helium neon laser beams, and they're going to convert analog film into a digital imaging. We used to have our film room techs. This became part of their job, where they started scanning all of the old film into digital images. You're not seeing film rooms anymore because all of that's been scanned now. But you do still have some doctor's offices and foot clinics, those types of places that still use a processor. And so in order to get those images to digital, we would have to scan them in. So looks like this. You put the radiograph in, that laser beam reads it, and then it converts it and stores that image. So this was a great way in the 90s, early 2000s. It saved the hospitals a lot of money by scanning all of their images in. Problem is, it can be very expensive long term, and there's a lot of maintenance, collaboration, quality control tests that need to be done. You know, those fluorescent bulbs need to be at full capacity, otherwise it doesn't read those images correctly. And plus you're having to pay someone to scan those images in for you. So it could take 80 seconds to scan one film. And then if there's a problem, you have to rescan it. So there's another, over 2-3 minutes for one piece of film. So it was a costly setup in the long run. So it was a quick, easy fix, but it does add up in cost long term. We also have teleradiology. So these films are transferred from off-site clinics to the main department for primary reading. So if you're working for an orthopedic group that's not part of the hospital system, they could still send their images to the radiologist to be read, and then the report would be sent back to them. So these are remote locations. So your radiologist is still going to be able to compare those outside films with old films and to give them a report. So new technology, we have computer-aided diagnoses that are being used in mammography and chest imaging. You've started talking about those artificial intelligent agents that we can use to read reports. So if they're looking for pneumonia, the programming in the computer is designed to pick that up. So there are some new upcoming devices that are being used. Our images for film printers, you receive an image from a workstation that's going to print the image. So just like you do with your printer at home with your documents from Word, you could do the same thing with your images on your computer. You could still print off a hard copy film for that person to take, but the hospital has to have that film printer in place. So a wet image is one that we talked about when we were using chemicals to process film. So you would have a wet film that came out. So had a lot of chemicals that would process that film. A laser beam produces an intensity of light proportional to that signal to receive the optical density recorded on your film. That laser is going to be a red light that's going to read. And that laser can also etch the images onto the film. Your film needs to be placed in a film magazine if you're using one of these devices, in a pretty well ventilated area because of the chemicals. So it's going to look something like this. You also have dry imagers that use heat to process a latent image etched onto a silver emulsion by the laser. So that film's going to get exposed by your laser and then get processed. These are going to take up a lot less space. They don't need a lot of storage areas, so you don't need a special location to store them in. And then it's going to look something like this, and it will print off your film. So your film can be used in a filmless radiology department. So we do have that capability to not only save them to a DVD, but to actually print out those films in some hospitals. Your outside physician offices is primarily where we're going to use these. So if they don't have a PACS system, I told you before, you'll print it or have your someone in the PACS department or in medical records will give them an actual DVD to take with them with the images stored on it. So typically we go that route rather than printing off those hard copy films anymore. So legal cases, any films that are printed to be viewed in court, it may be more commonplace to have a computer access in the courtroom nowadays where they can show the digital images rather than the printed films. So how Cindy and I are always getting on you about keeping those markers on your film because of legal purposes. Your films could still be printed, they could be put on a DVD, or they could be sent electronically to the court. We are allowed to print off images for teaching purposes, so that is not a HIPAA requirement if it's something that you're doing educationally. So for training purpose or education purposes, we can look at patient records. So your film printing is a costly part of PACS, and so a lot of places don't like to have to do that because number one, you have to pay for the DVD. You have to pay for the manpower to save it to the DVD. It's just easier if everyone has PACS where we can send that document right off through an electronic version. So those burners, if we do have to burn an image to our DVD, there's a laser that will burn a tiny depression onto the data that's being saved onto that disk. So all PACS vendors offer the ability to burn images. So even if you went to the Dell Works, there's a capability to burn what image you took on that screen onto a DVD, and you could take your image home. When your disc is burned, that patient's information is also going to be on there. So if they're taking it to another physician, it does have the information on that disc. So when you put that disc into the drive, the software is automatically going to launch and it will display those images. So they could go home and they could put it onto their laptop and they would be able to pull up those images. So this is what it looks like when it's ready to the CDR. The disc can be used in the same application as printing films. They're really cheap, so you're looking at one sheet of dry laser films about 48 cents, where a CD is going to cost you about 28 cents. So that's why a majority of them have just gone to using the DVDs or CDs. All right, so take a look at this chapter. I know it seems like there's a lot of information in there, but once you start reading it, a lot of it's things that you've already heard us talk about. So I don't think there's anything really too new in that chapter. Then once you get through that, submit those answers to the review questions and make sure you take your quiz by Sunday. Have a great rest of the week. Bye-bye.